Hello everyone, we are from Phatthalung School in Phatthalung, Thailand. For our presentation today, we'd like to explain how our smart drying machine in agriculture is still the main occupation of Thai people, including where we live in Phatthalung province. In Phatthalung, there are 4 districts near Songkhla Lake, where the main occupation of the local people are fishing and food processing from fisheries. The production of dry fish products, in particular, such as lubei fish, sun-dried gourmet, and catfish are quite popular and are sold under the local entrepreneurship government stimulus program. Most of the local fishermen use the sun-drying method for their products, which unfortunately has several limitations, including the length of time needed to dry and dust and germ contamination. From our study, it was found that the conventional fish drying machine generally had a temperature of 50 to 55 degrees Celsius, but had one obvious big problem. These machines could not warn user of the dryness level of the fish. Therefore, the quality of the fish could be affected. As a result, we came up with a smart drying machine that differs from conventional drying machine by adopting the principle of blackbody radiation and natural insulation to reduce heat transfer from inside to outside. Hence, as the temperature inside our smart drying machine rises, an embedded board and sensor measure the temperature and the relative humidity inside and outside the drying machine to analyze and turn on and off the humidifier fan and notify the user of level of the dryness. Design and build. Our smart drying machine was designed based off blackbody radiation theory, reduction of heat transfer, and Arduino ESP32. There are 3 components in our smart drying machine. 1. A light receiving parabola dome. We made it by using black metal and we formed it into a parabola dome shape. After that, we cover it with a polycarbonate sheet and a clear acrylic sheet to absorb the light rays, and keep it in our smart drying machine. After the light rays are absorbed, there is a radiation which the ray can pass the polycarbonate out, so it makes our smart drying machine temperature rise higher. 2. Smart drying machine base and reducing heat transfer. We made the base by painting the metal plate black to absorb the light rays and emit radiation around the side of the box. There are 3 layers of heat insulation. 1. The first layer inside the box is an aluminum foil sheet that reflects the heat rays and keeps them in our smart drying machine. 2. The middle layer is made from durian fiber and has low thermal conductivity and is eco-friendly. 3. The third layer is outside the box and made from foam board. It not only acts as an insulation material, but it also has made our smart drying machine hard and not easy to break. 3. Automatic humidifier fan and automatic dryness notifier circuit, included by Arduino ESP32 board and the S214 humidity temperature sensor,
which is the S214 sensor will measure the internal and external temperature and humidity. After that, it will send the data to process at Arduino ESP32 board and command the fan automatic dryness notifier to activate. Creating and performance testing of smart drying machine. After we build a smart drying machine, we test its performance and analyze the data for coding using the following steps. First, we compare the DHT22 sensor with a standard measuring tool. By using the DHT22 sensor and a standard measuring tool in our smart drying machine, we learn when the machine was empty and when to put more fish in. We collect the temperature and relative humidity data, both inside and outside the machine, by using the DHT22 sensor, a hygrometer and a thermometer. Then, we compare the different values. We found that the data value differed by only 0.5. Second, we use the data for coding to control the automatic turning on-off of the humidifier fan and for dryness level notifier. There were 4 types of dried fish in our experiment: catfish, gourmet, lubei, and mackerel. We found that the relative humidity was slightly increased when the fish were wet. The relative humidity differed by 6 to 10 from the inside and outside, and the relative humidity slightly decreased when the fish dried. The relative humidity differed by 0 to 3 from the outside. We use this information for coding to control the automatic turning on-off of the humidifier fan. If the internal relative humidity is higher than 5 or more, the humidifier fan will work, and if the internal relative humidity is less than 5, or if the internal temperature of the machine decreases by more than 2 degrees Celsius, the fan will stop working. After that, we use the information for coding to control the food dryness level notification. If there is no change between the internal relative humidity of more than 3 for 30 minutes, there will be a dry notification sent, which means the food has a dry standard humidity between 40 to 50%. If there is no change after 90 minutes, there will be a medium dry notification, which means the food has a dry standard humidity between 21 to 40%. And after 150 minutes, there will be very dry notification, which means the food has a standard humidity less than 20%. For the next step, we check the efficiency by observe the temperature increase in a smart drying machine, testing the operation of the humidifier fan control system, testing the function of the food dryness level notification system, drying fish of a similar mass inside and outside our smart drying machine.